In the next two problems, we have a complex rational expression because we have fractions within fractions, and then we have a subtraction problem. In both complex rational expressions and in subtraction problems, we do need common denominators, but we use them in different ways. In a complex rational expression, the shortcut method involving an LCD is that you look for the LCD not of the overall fraction, but of the smaller nested fractions. So when I look at the smaller nested fractions, I've got 1 here in the numerator, 2 over n minus 1. So the LCD is going to have n minus 1 in it. And then in the denominator, I have 1 over n minus 1 and 1 over n minus 2. So I already have the n minus 1 in my LCD, so I'm going to have an n minus 2 there as well. What we're going to then do with the LCD is instead of rewriting both top and bottom with it, we're going to multiply the entire fraction by n minus 1 times n minus 2, the LCD, on top and on bottom. And the reason this works is because technically we're multiplying by 1. The LCD over itself is 1, so we're not changing this fraction. Now we need to be careful and distribute that LCD to all terms in the numerator and in the denominator. So you need to make sure you distribute carefully. And then we should eliminate all of those nested fractions. But you need to be careful as you do this to make sure you only cancel what you can. So in the first fraction, when I distribute the LCD, there is an n minus 1 that cancels, so we'll have the 2 in the numerator times the part of the LCD that doesn't cancel, which is n minus 2. In the second term in the numerator, minus 4, it has no denominator, so none of the LCD cancels. In my denominator, in the first fraction here, I have 1 over n minus 1, so n minus 1's cancel, so I have 1 times n minus 2. And then I'm going to add to that 1 times the n minus 2's cancel, so I'm going to have n minus 1 left. Now at this point, notice all of the nested denominators are gone. You have a single numerator, single denominator, if you don't count that there's a whole bunch of terms that we need to add up in them. But you no longer have nested fractions. That's the good news. Now we do have a bunch of multiplication and addition subtraction to do. Remember, multiplication comes before adding and subtracting. So let's do some distribution. 2n minus 4. Here I'm going to leave the 4 for the last. I'm going to FOIL out the n minus 1 and the n minus 2 first. So n squared minus 2n minus 1n would add up to negative 3n when you FOIL and collect like terms, and then plus 2. So that's my multiplication of the LCD out. In the denominator, when I multiply by 1, I just get what was there, n minus 2 plus n minus 1. Continuing to do my final multiplication in the numerator, 2n minus 4 minus 4n squared plus 12n minus 8. I can collect like terms in the denominator because I don't have any more multiplication in that to do. And then finally, in my next fraction, I can collect like terms in the numerator now that all the multiplication is done. So negative 4n squared plus 14n minus 12 all over 2n minus 3. So that's the fraction simplified in terms of collecting like terms. There may be a common factor though. The only way to figure out if there is a common factor is to factor that numerator and see what we get. I see that it starts with a negative, so I'm going to factor a negative for sure. Each of those numbers in the numerator is even, so I know there's a 2 there, so I'm going to factor the 2 as well. When I take a 2 out, I'm going to get 2n squared minus 7n plus 6. Watch your signs. My denominator is still 2n minus 3. We may be able to factor that trinomial in the numerator. Let's give it a shot. It's a trinomial, so going to a binomial times a binomial. 2n times n. 6, I could use minus 2 and minus 3 to give me a positive 6, and if I multiply that out, it does give me a negative 7n, so it did factor. And luckily, it factors very nicely because my denominator was 2n minus 3, so I actually am able to cancel those common factors out and end up with a final answer, which is much simpler than where I started, of negative 2 times n minus 2. I don't have to write the over 1 because remember, when we have a denominator of 1, it can be thought of as not being there. Because when you divide by 1, you still remain where you are. Now, we did simplify one thing here. So we should say what our restrictions are. We simplified out 2n minus 3, so we should say that n is not equal to 3/2. We also did some cancellation up here at the top with this LCD. In particular, I canceled the n minus 1s, so n cannot be 1, and I also canceled n minus 2s, so n cannot be 2. So it turns out we do need to go all the way back up to anything we canceled throughout the problem and list those exceptions out. So there's some domain restrictions, but overall this simplified quite nicely. In the last problem on the page, we have a subtraction. Definitely different denominators here, so to add or subtract, we need those denominators to be the same. Let's start by factoring them and seeing what we've got. So my first denominator, x squared minus 3x plus 2, factors to x minus 2 times x minus 1. My second denominator is going to factor x squared minus x minus 2 to x minus 2 times x plus 1. So notice both of these denominators had an x minus 2 in it. So we're not going to have to multiply them all together. We're going to have to just pick and choose. So let's start with the first denominator, x minus 2 times x minus 1 in our LCD. And then the second denominator has the x minus 2 there, so I don't have to add that in. I have to add what's missing, which is the x plus 1. So my LCD will be this product of 3 binomials. So I'm going to rewrite both fractions that way. X minus 2 times x minus 1 times x plus 1 for my first fraction in the denominator, and the same thing in my second fraction in the denominator. Now I have to adjust the numerators appropriately. And in the first denominator, I put in an extra an x plus 1. So I have to adjust my x in the numerator by multiplying by x plus 1. In my second denominator, I put in an extra x minus 1. So I'm going to multiply my second numerator by that extra factor that came into the denominator, which is x minus 1. So that builds both fractions to be bigger, but it's going to allow us to have that common denominator. So my common denominator I can now pull together with the fractions with that same common denominator, and then I can subtract the numerators, but I do need to multiply them out as I subtract. So x squared plus x when I distribute the first numerator, and then technically this is minus 3 times x minus 1, so minus 3x minus 3 times the negative 1 is positive 3. Remember, you are subtracting all of the terms there, so you might as well do it as you distribute. Collecting like terms in the numerator, I get x squared minus 2x plus 3 over x minus 2 times x minus 1 times x plus 1. We might be able to factor that numerator to simplify the entire fraction. Let's give it a shot. X and x, factors of 3, 1 and 3, they will not add up to negative 2 though. So even though I started trying to do it, it's not going to work. So I can't factor that numerator. So where I ended right here is my final result. And I didn't cancel anything, so I don't have any domain restrictions that aren't already shown in the final result. So there would be my answer to the subtraction problem.